Class today is about Karnaugh Map, or known as K-Map. What is K-Map or Karnaugh Map? Karnaugh Map provides a systematic method to simplify Boolean expression and produce the simplest standard of product, which is SOP or POS expression, product of sum. K-Map also is used to minimize the number of logic that required in a digital circuit. K-Map is similar to a truth table because it presents all the possible value of the input variables and the resulting output for each. Let's take a look. For example, if you have a K-Map with the two variable, which is you get f equals to AB plus AB bar. So the variable is only A and B. So for this variable A and B, you will have 4 cells for K-Map. For 3 variable, for example, you got f equals to ABC plus ABC bar bar. So the variable is A, B, and C. For 3 variable, you will have 8 cells. 4 variables, for example, you got f equals to A, B, C, D. So plus A, B bar, A bar, B bar, C bar, D. For example, so this is considered 4 variables where you got A, B, C, and D. If for 2 variables, you will have 2 times 2 maps, which is like that, 2 times 2. For 3 variables, you will have 4 times 2, which is 3 variables. This one is A and B. For 3 variables, you will have 4 times 2, which is this one is A, B, and C. C is 0 or 1. AB can have 0, 0, 0, 1, 1, 1, 1, 0. For 4 variables, 4 times 4. So 4 variable, 4 times 4 means that you got A, B, C, D. A, B, C, D. So for this one, you will have 4 times 4, like that. 1, 2, 3, 4. 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. So if you have 5 variable, for example, A, B, C, D, and E. So this one you will have 8 times 4. Like that. 1, 2, 3, 4, 5, 5, 6, 7, 8. We divide them and divide by 4. Like that. Okay. Alright, this is example for cell adjacency. So you can wrap, and this one is adjacent, very near. So this is example of 16 cell. 4 times 4. For this one, you will have 4 variables, which is A, B, C, and D. Okay. For K-Map SOP table construction. For this one, this is examples for 2 variables, A and B. So for this cell, it starts from 0, 1, 2, 3. 0, 0 is 0, 0, 1 is 1, 1, 0 is 2, 1, 1 is 3. So for 2 variables, it's only count from number 0 to number 3. So you read as 0, 0, 0, 1, 1, 0, 1, 1. So this is example for 4 times 2, which is 3 variables, A, B, C. So for this arrangement in the K-Map, so you see, for 3 variables, you got 0, 0, 0, 0, 0, 0, 1, 1, 0, 1, 0, 2, 0, 1, 1, 3, 0, 1, 1, 0. sorry, so this one is 100, 101, 110, 111. For 3-bit binary, 000, 001, 010, 011, 100, 101, 110, 111. So it's come from number 0, 1, 2, 3, 4, 5, 6, 7. So you see the arrangement in the, which is this one is A, B, C. In the truth table, so it starts 0 here, 1, 2, 3, 4, 5, 6, 7. So you have to remember the arrangement in the K-map. So it will be easier for you to map them. Because some of the question, they will give you, for example, F equals to A, B bar, C, plus A bar, B bar, C, plus A bar, B bar, C bar. So this one, you will locate the location. You will need to locate all these location in the K-map. For example, in this question, so you got 1, 0, 1, 0, 0, 1, 0, 0, 0. So you will need to locate them 1, 0, 1, 1, 0, 1, 0, 1. For example, here 0, 0, 1, 0, 0, 1 here, 0, 0, 0, 0, 0, 0 here. So this is the way that you will have to locate the this equation in the K-map. Otherwise, there is some question where you can get like this: F equals to A, B, C, D, like that. Sums M equals to 1, 3, 4. So if they give you the number like that, so you will have to remember all this number over here, the arrangement number in the K-map. So you will need to locate 1, 3, 4, which is 1 here, 3 here, 4 over here. So most of the students, they miss this one where they locate this one in the wrong way. So remember, it starts 0, 0, 0, 1, 1, 1, 1, 0. Okay, this is example for 4 variable K-map. 4 variables means, remember, you got A, B, C, and D. So the arrangement in the K-map start like that: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If you remember this also, you will be good already. 0, 0, 0, 1, 1, 1, 1, 0. It's not 0, 0, 0, 1, 1, 0, 1, 1. It start 1, 1 first, then 1, 0. Same on this way: 0, 0, 0, 1, 1, 1, 1, 0. Okay, so this is example of POS. So by looking at this equation, you know that it is POS. When POS, you need to write a 0. What is the difference between SOP and POS? For example, you got A and A bar. A bar. For SOP, you read A as 1, A bar as 0. For POS, A is 0, A bar is 1. The way that you locate in the K-map, for the POS, you will write 0. You will read 0. Okay. In this K-map, is 3 variable. So you got 0, 0, 0, 0, 1, 0. A bar is 1, B bar is 1, C is 0. A bar is 1, 0, 1. So this way you locate 0, 0, 0 is here, 0, 1, 0 is here, 0, 1, 0, 1, 1, 0, 1, 1, 0 here, 1, 0, 1, 1, 0, 1 here. Okay, this is the way that I teach you how to locate them in the K-map. This is example for variable K-map. For the A equation, for example, F equals to A plus B plus D times C plus D times A bar plus B plus C. So this is the equation. You already locate them in the K-map. So this is example for simplification. So if you have location like that, you can do simplification by grouping this number of 0 like that. You see A and B for this 4 0 change from 0 1 1 1. So it changed state, so you don't read A. For the B, 0 1 1 0 change state, so you don't read B for this for this for number of 0 group. C and D, C doesn't change state, D doesn't change state, so you read C plus D. Okay, settle for group number of 0. Then you can group this one and this 0. So you read this one and this one. So in this way, you see A and B doesn't change state. Only A is 0, B is 0. So in this way, you read A and B on this row. So on this row, C and D, you see C change state from 0 to 1. So you don't read C. How about D? D change from 0. D doesn't change from 0 to 0. So D, you read D. So you got A plus B plus D. Okay, settle for group number 2. Now we go to the group number 3. Okay, group number 3. So you read this one and this one. A bar B. So A bar B, so doesn't change state, only have one A, one B. So you read A bar B for this side. Okay, for this side, you see C and D. C, 0. C over here is 0. So C doesn't change state, so you can read C. How about D? D change state from 0 to 1. So you don't read D. So you read C in this way. So you got A bar plus B plus C. So you got this equation for this 4 times 4 K-map variable for A, B, C, D. So this is example for 2 variable K-map where one is grouping, one is not. One, if it's not grouping, you read one by one. It's also correct, but it's not simplified. For this one, you read A bar, B bar. For this one, which is this one. For this one, you read A, B bar. So this one. So you got X equals to A bar, B bar plus A, B bar. You can simplify this by doing grouping like this. If you group like this, you have to compare between A and A bar and B. A and A bar, so it changed state from 0 to 1. And B doesn't change state, so you read X equals to B bar. You see, it's simplified, right? Okay, this is example for 3 variable K-map. You got X equals to A, B bar, C bar plus A bar, B bar, C bar plus A bar, B bar, C plus A, B bar, C. So this one is 1, 0, 0. This one is SOP. By looking at this equation, you know that this one is SOP. So you read SOP 0, 0, 0, 0, 0, 1, 1, 0, 1. Okay, 1, 0, 0. So 1, 0, 0 is here. 1, 0, 0. 0, 0, 0, 0, 0, 0, 0, 0, 1. 0, 0, 1 is here. 1, 0, 1. So 1, 0, 1 is here. So I will show you there is a few steps to do minimization for this kind of equation. For number 1, minimization. For example, you have like this, you can group this one to 2 group. So what happen if you group them into 2 group? So you got this one, you group number 1, and this one is group number 2. For the group number 1, you got A, B, A bar, B bar. So A and B doesn't change that because it's only have one A and one B. So you read them as A bar, B bar, like that. C change state, so you don't read C. C change from 0 to 1, this way. Okay. For the group number 2, A, B bar, so only have one A, one B bar, and C change state, so you read as A, B bar. So from here, standard SOP, so you can get non-standard SOP by boolean simplification using Karnaugh Map. X equals to A bar, B bar plus A, B bar, rather than you have this one. Okay, next. You can do simplification like this. By grouping this way, one group, this one, two group. This one is between this one and this one, and this one and this one. So by grouping this way, so you will compare this one and this one. Okay, for the group number 1, A bar to A. So it changed it for A bar to A. So you don't read them. B bar, both of them B bar. So 0. So you read B bar this way. C doesn't change state because in this way C is 0. So you got C bar. So that is for equation number 1. For the equation number 2, you compare between this one and this one as well. So A change state from 0 to 1. B is B bar. So you read B bar. C doesn't change state. C is only C. So you read C. So rather than this standard SOP, you go to non-standard SOP simplification. You got this equation, which is X equals to B bar C bar plus B bar C. Okay, this is another way for simplification. From this standard SOP, you can group 2 times, you can group 2, 4, 6, for example. So this one, if you group like this, you will compare between this one and this one, this one and this one. So for A change state from A bar to A. So you don't read A. B is okay. So you read B bar. So how about C? C change state this way from 0 to 1. So you don't read C. So rather than you have X equals to A, B bar, C bar plus A bar, B bar, C bar plus A bar, B bar, C plus A, B bar, C. So you will do a boolean simplification. You got only X equals to B bar. Okay, that's all for my class today. I will continue for the next chapter. Thank you very much for your listening.